Servus, New York City. My name is Arkadiusz Borucki. I work for Amadeus Data Processing in Germany as senior SRE engineer. Today I will be talking about MongoDB deployment at huge scale. So I will tell you and show you what we deployed in our huge data center in Erding, Germany. Before this, let me give you a short overview about Amadeus. Amadeus is one of the leading technology companies in global travel industry. We are one of the top 15 software companies in the world. Let me give you some numbers. Last year, in our data center in Erding, we had more than 630 million of total bookings. Our software helped board more than 1.6 billion passengers. So basically, when you are booking some tickets online, there is huge possibility that your query or transaction will go to our Erding data center. Our offices are all over the world. The headquarters is in Madrid, in Spain. As I told you before, our big data center is in Erding, Germany. But also we have offices in Nice. There is R&D center. Our developers love MongoDB. We have also offices here in US, in Boston, also in Miami. We are also in Sydney, in Brazil, in China, in Tokyo, and in Poland. Today, I will tell you what we are doing with MongoDB, because our farm is a huge one, so we are deploying everything at huge scale. Let me give you some short overview what we have in Germany. We are using Ops Manager. So our clusters are split between 4 Ops Managers. How it looks? We isolated production and we put production into production Ops Manager. Everything else, which is not that critical, goes to DevOps Manager or Test Ops Manager. At the top, we have Master Ops Manager. This Ops Manager is in charge of our other Ops Managers. Why we use Ops Manager? We use Ops Manager for a few reasons: for backup, automation, and monitoring. If you are running such farm, I not think this is possible to operate it without Ops Manager. At this moment, we have around 100 MongoDB clusters. Size is from, let's say, 100 gigabytes to real big ones over 107 terabytes. So this is, let's say, database at huge scale. And then I will show you how to operate this. What is meant 100 MongoDB clusters? We have around 574 nodes, physical servers or virtual machines, because production runs on physical machines. Everything else, like dev, like scaling, like test, runs on VMs at this moment. We are building in-house MongoDB as a service, but at this moment it doesn't exist yet. We are using micro-sharding. What is micro-sharding? When you are using huge hardware for your database, so in our case, huge hardware is, let's say, 1 terabyte of memory, it's a good idea to use more than 1 MongoDB per machine. In the biggest case, we are using 64 MongoDBs per 1 machine. We do this because we want to utilize hardware as much as possible. But to make sure that everything is up and running, we are using automation. So we had to automate it. And automation, with help of course, Ops Manager, is helping us to make sure everything is working well. If I'm talking about automation, I'm talking about different technologies, like Jenkins, continuous integration and continuous delivery pipelines, like Ansible, Playbooks. We are using REST API calls to Ops Manager. We are also using Python. What is also very important to mention is security. Our company has PCI DSS audits every year, and we need to make sure everything is as secure as possible. So we are using everything what MongoDB can provide us, which is SSL for data in move. We are using Kerberos and LDAP for authentication and authorization. We have our own CA. We integrated our farm with QRadar, so we are able to have auditing. And also, in some projects, we are using encryption at rest. Use cases. We have lots of use cases. And lots of new projects goes to MongoDB. The most famous one is Amadeus Instant Search cluster. So this is flight recommendation data. I will tell you a few words about this cluster soon. We are using MongoDB for real-time analytics. So this is use case with micro-sharding. We are running Apache Spark jobs on MongoDB for fraud detection projects. We are using MongoDB for Amadeus payments projects. We have NextTI, Next Travel Intelligence project. So this is a business intelligent application which will help our customers in decision making. Also, we are using MongoDB for our internal use cases, like all kind of dashboards, change viewers, application viewers, and so on. Amadeus Instant Search. So this cluster, this project is a set of 3 clusters. At this moment, we have in total 200 terabytes of data, which is absolutely huge. And this cluster, this project is growing. So I know that in the next couple of weeks, we will add additional 100 terabytes to this project because we have more and more customers on this cluster. What is Instant Search project? So this is flight recommendation data. So we have billions of recommendations, and our customers are able to search this data in very short time. So in the average, we have 2 milliseconds. What kind of, if you want to use this cluster, for instance, use Kayak. So if you use Kayak for flights searching, you will go with our MongoDB SSP project. Also, for instance, Skyscanner. How we are doing it? In our master computation platform, we are pre-compute results. We are encapsulate them into JSON files, and we push this to MongoDB. And from MongoDB, our customers can search flights. Of course, we need to make sure that our data is always valid. That's why we need to replace everything. 200 terabytes in fresh data every 3 days. At the same time, our customers must be able to searching flights. So you can imagine how many operations are going there. So we are getting quite good results. What is also important, this cluster must be always online. If we do some maintenance, if we are rebooting nodes, we need to make sure operation will be transparent for application. Let me show you this cluster. So this is 50 nodes. This is physical hardware. Our processes are distributed across this cluster. So we can see that this is database with 50 physical machines. Yeah. And every month, we need to reboot everything in rolling way. Yeah? You know for why? For kernel. Because according to PCI DSS, we need to always have the latest kernel. And we are doing this in rolling way. I will show you this later. If you have a look, here you can see shards with replication for fault tolerance. So in total, in this project, we have 104 shards because we go from 0. Let's see metrics. So at this moment, this single cluster has 100 terabytes. But as I told you, we are continuously adding new nodes, and we are putting more and more search results here. One shard has around 1 terabyte. If you go inside in Ops Manager, you can see metrics. So if you want to do performance tuning on such machine, the best place to start is Ops Manager. So this is single point of view for such huge database. And here is everything, including hardware statistics. And you can also add your charts wherever you need. Let's see real-time analytics, because we are able to see what is going on in real time. So we can see memory utilization, network, operations. So here we can see CPU utilization. We can see the hottest collections, because we have one collection per customer in this case. So we have several customers which are using this cluster with isolated data. One customer per collection. Performance advisor. We see we don't have any slow operations. Nothing to tune. Yeah. So this is how looks the biggest cluster. Okay, but how to operate at such scale? Automation. So without automation, it would be very complicated. You can imagine you have 3,000 of MongoDB processes in total, and you need to figure out how to manage them, how to do maintenance, how to reboot everything in rolling way, and so on, so on, so on. So you need army of people, or you need automation. What we are using? We are using infrastructure as a code, which means we keep configuration in central place in Bitbucket to make sure we have consistency. We are using Jenkins, continuous integration and continuous delivery pipelines. If you want to orchestrate our deployment, I will show you a small demo about this later. We are using, of course, Ops Manager and REST API provided by Ops Manager. We developed Ansible modules and playbooks and roles for MongoDB and Ops Manager. I will also show this later. So we have our framework for online database upgrade, for rolling kernel upgrades, and so on, so on. We are also working on MongoDB as a service, and maybe next year we will show you something related to this. Here we have small live demo how we do kernel patching. So in this case, we have 3 nodes, and we need to, when you are doing such operation, you need to reboot everything. In this case, we are using Ansible Playbook. Our Ansible will jump on every node and will do following stuff. MongoDB pre-health checks, check kernel version, install new version, stop MongoDB on one node, reboot node, start MongoDB, do post checks, and jump to other nodes from the list. So let's run Ansible. So we are refreshing repository. We are checking processes health. We are installing kernel. Stopping Mongo just on one node, because this operation must be transparent for application. So application cannot be able to see it. And we see that Ops Manager stopped Mongo on first machine, and now this machine went down for reboot. After start, we are starting automation. Automation is starting MongoDB. And as we can see, operation is done on first node. Now, automation will jump to second one and will repeat exactly these same steps. In this case, we have just 3 nodes. If you have 50 or 60 or 100 nodes, you should do this exactly like this. If you are running MongoDB in your data center, of course. So now second node is down. And after reboot, automation is starting, MongoDB is starting, and second node is OK. Now let's jump to last node. Automation via REST API stopped processes, install new kernel, reboot node, and after reboot, everything is up and running again. So it was a short example how to do security and kernel patching on MongoDB. As I told you, we are using infrastructure as a code. So we divide our Bitbucket for 4 branches. So we have dev branch, TL1 branch, TL2 branch, and production branch. Every changes which we want to implement goes first on dev or TL1. If everything is fine, those changes goes to TL2 phase. Of course, we have databases related to those phases. And if everything is up and running, we are applying our changes on production. So this reduces really overhead and eliminate human mistakes. My favorite subject, Ops Manager REST API. We are able to do all those operations because Ops Manager provides REST API. So we are not clicking anymore in Ops Manager. We are able to do REST API call from our automation, and our automation will tell Ops Manager what to do and how to do. Ops Manager provides you JSON entities, which is very good for human for reading, and also very easy, for instance, with Python. There is JSON module to automate this. So we are using Ansible, Python, and sometimes Puppet, and those tools talks to REST API, and REST API is triggering changes into Ops Manager, which is triggering changes on MongoDB databases. What we did in-house, we developed Ops Manager class in Python. So our automation is based on Ops Manager class. This Ops Manager class provides several methods. For instance, if we want to put maintenance window on cluster, we are just using our class which will trigger those changes. For instance, one method can do online MongoDB upgrade, which I will show you soon. We can also check cluster health, or we can shut down database on one node if we want to take this node from maintenance, or if we want to do kernel patching, which I showed you. This demo will demonstrate how to upgrade MongoDB database via REST API. And we are using our Ops Manager class in this case. So our Python, we need to provide on input username. API key, ops manager name, port. We want to log everything. We love security. That's why we are using certificates. We want to upgrade, cluster test Amadeus, and we want to go to version 3.6.3. And let's start. So first, automation is checking alerts, no alerts. We are checking replication. Replication is in good condition. We need to set maintenance window on cluster to make sure no one else will use this. And we put our changes via Ops Manager REST API. And now every 2 seconds, automation is checking if Ops Manager is still deploying changes. Let's see if we really have maintenance window. Here we go. So there is maintenance window on our cluster. So no one else will trigger some actions. And in background, Ops Manager is upgrading MongoDB database. So we can see that config servers are ready. And our cluster soon will go into version 3.6.3. And we are done. Online upgrade. Transparent for application. We can see that automation did post health checks. So after upgrade, we don't have any alerts. Replication is in good state. So we need to delete the maintenance window. Let's double check if maintenance window has been removed. Nothing. And we are done. So this is how easy it is. So we have several more methods, like delete maintenance window, check if Ops Manager is still deploying changes, and also you are able to get any kind of statistics about your deployment from Ops Manager. So you need to just make sure you have correct REST API call for it. Another live demo, we will show you how we deploy clusters. So in this case, we need to create new organization and new project in our Ops Manager. We don't want to click this. We want to do everything via Ansible. We can see that we have roles in our Ansible playbooks. So we have NoSQL facts, NoSQL users, NoSQL kernel parameters, file system, and MongoDB role. So everything which has been written in this playbook will configure our machines. So we will add users, tune kernel parameter, create file systems, and everything what you would do manually. And also, our automation will create new group with Ops Manager. Let's see how it works. Here is just inventory files. So we want to create our cluster with those 3 nodes, and Ansible will do configuration of our hardware. What we need to do, we need to just add cluster name. So in this case, this will be 2018 New York City. So this will be our cluster name. Let's run playbook. And here we go. What Ansible is doing now is making changes on our machines, including security. So it's creating certificates, is deploying Kerberos, is creating file systems, installing automation agent binaries, and so on, so on, so on. Everything what you would do manually is done by this Ansible. It's fast and clean and consistent. Let's refresh Ops Manager, And we can see that we have new organization created via REST API call. We have new cluster. And we can see 3 empty nodes at this moment, because I want to show you how to deploy database now. I could do this in one go, but for this presentation, I went into some details. So now we need to prepare JSON with cluster configuration. So this Python will prepare JSON file with cluster configuration. We see that our cluster is New York City 2018. We want to have 6 shards. We need to provide ops manager name on input. And what happens? Our Python created JSON file with new cluster details. Let's go inside for a quick look. So in this JSON, we have everything which is necessary to deploy new cluster. So every single MongoD or MongoS process has parameters in this JSON, including security, including cache size, everything. And now, what we have to do, we need to just push this JSON into Ops Manager. Yeah, so we need to put, again, username, API key, and let's see what happens. We push JSON to Ops Manager, automation discover it, and building MongoDB database with 6 shards. If you want to have 12 shards, you need to just put different parameter on the input, and it's done. This is how we deploy MongoDB databases in Amadeus. We don't do this manually anymore because it's time-consuming and you can get some inconsistencies, some errors, and so on, so on. Ansible. As I told you, we use Ansible, and what we did, we developed in-house Ansible dedicated modules for MongoDB, for starting, stopping, alert checking, replication set checking, and so on, so on. So our automation, in fact, is triggering Ansible, and this Ansible is using Ops Manager class, wrote in Python, and this is how our operations looks like. And good news is we open source everything. So on Amadeus official GitHub account, you can find our automation, and you can just take it, have a look, maybe give us some feedback, test it, use it. So everything which I showed you is open source, and we will open source much more things with time, of course. Also, we put on Ansible Galaxy our MongoDB playbooks, roles, and modules. So you can take everything if you are running MongoDB deployment, and you can test it. Everything is free. Just have a good fun. The last part is Jenkins. If you are running automation, you need to think about orchestration, because sometimes you have lots of automation processes, and you need to make sure they are starting in right order. So for instance, process C will not start if process B will not be successful. We decided to start using Jenkins for it. Jenkins is easy to integrate with repository. In our case, we integrated via Webhacks Jenkins with Bitbucket. So if we push any change to Bitbucket, Jenkins will discover this change and will start doing our operations. So if we want to, for instance, schedule some Ops Managers upgrades, We are not doing it by copying RPM files into nodes and stopping Ops Manager, upgrading this manually. We hard-coded everything in Jenkins pipeline. And in this way, we will upgrade, in this example, Ops Manager. But you can use this and automate wherever you want. I have, of course, live demo. Let me run this. So this is our pipeline for Ops Manager upgrade, including, of course, pre-health checks, action, post-health checks. But if we want to start, we need to change something in our Bitbucket repository. So we have here Ops Manager repo, Ops Manager upgrade repo. We need to take it on our, we need to clone this first, of course. So let's clone this. Let's go inside. So here we have few files like config, like Python, which will trigger a REST API. But what I want to show you is Jenkins File. In Jenkins File, if you are using pipelines, you need to hard code your process. So you need to orchestrate this via Jenkins File. What you can see here, all those steps has been hard coded in Jenkins File. So now, if we change anything, for instance, let's do some small change. I just want to show you how Jenkins will trigger action. So just let's add MongoDB War 2018. Of course, we need to add this. We need to commit it. And we need to push it. And now, what we can see, Jenkins has discovered that something has changed, and now is running pipeline. Is opening ticket, is taking Ops Manager credentials, is doing pre-health checks, is copying Linux RPM files into nodes, stopping Ops Managers on free nodes in this case, upgrading Ops Manager. Actually, Jenkins is triggering Ansible in real world. Starting Ops Manager, post-health checks, closing TR, and we are done. So this is how we started do IT operations this year, actually, because we are still changing this process, we are still developing it, but this is our idea how to run IT operations. The last slide, I will tell you what we are working on now. So there is one project which will require 200 terabytes MongoDB cluster, which will be totally monster, which will be totally huge one. We are thinking about OpenShift. We are starting using S3 Object Store for Ops Manager backup. So few projects already keep backup on Object Store. We are starting migrations from RDBMS to MongoDB. So we have lots of stuff. This year we should kick off first projects. Amadeus will be writing technical blog with MongoDB, so all those hints will be available soon. And of course, we will open source more and more things with time. We also recorded this as a webinar, so you can find this on MongoDB website. Thank you very much for coming.
Thanks, Arkadiusz. We have about 4 minutes for questions. So if you want to raise your hand, if you do have a question, we'll get this microphone to you so everyone can hear it. Over here.
Hi, my name is Fan. I'm from Zimbox, a MongoDB startup company. I'm so impressed about the presentation. Okay, so I have one question related to some tough MongoDB maintenance job. I'm not sure if you guys can help us develop some tool. For example, building new index after deployment and remove some old data and backup and restore and rebalance when you add and remove shards.
So
those are very challenging jobs for us.
So in this case, I would suggest check Ops Manager documentation, because there should be some JSON file which will give you this possibility.
Yeah, but each job takes for maybe 1 day, 4 days, okay, to finish my job. Technically for your 200 TB, I'm pretty sure you will last for 1 day to do one single job. So how could you help us monitor the whole process?
Very good question. Yeah. Yeah.
Yeah, so each time, for example, create a new shard will be very easy, but do other maintenance job. For example, there's such a big across 200 TB, create a new index will take for a very, very long time. So how to monitor this kind of progress? For example, you create a new index. Remove data, maybe I think it's very difficult, okay, for this kind of 200 TB, okay, the cluster. So how could you monitor this kind of progress?
Actually, I would start from Ops Manager. I would start to check in Ops Manager if you don't have any statistics for this. Yeah.
So in one of the early slides, you had some architecture diagram where you had a master option deployment and then other option deployment. Why do you use that? Like, how does it work?
Okay, because Ops Manager is not able to monitor himself and backup himself. So we use Master Ops Manager because we want to make sure we have backup of internal database of our Ops Managers, and we want to monitor Ops Managers somehow. That's why we use this.
Same thing here, like 500 plus nodes, and then you add like 3,000 MongoDB.
Yeah.
So how are you defining how many MongoDB nodes, MongoDB processes you need on each?
Okay, because we are using micro-sharding, that's why. So in some project, this is up to hardware, actually. If we have huge hardware, we are able to put 64 MongoDB per one node. So that's why you saw this different.
Time for one more question over there. You were first.
I've seen that you committed something to change to configure the ops manager of the Jenkins File. Why didn't you choose directly to go to Power, for example, instead of Jenkins?
This is a very good question. And this is up to use case. We are also looking at Ansible Tower, and we are also looking at Jenkins pipelines. Yeah, so this is a very good question. You can use both.
All right, so we're at time. The good news is Arkadiusz will stick around and sign autographs. I don't think he will. But pretty impressive, right? So thank you again, Arkadiusz, for the time and reviewing the work you've done.
Thank you.